In this video, I want to share with you how and why I got from this
Slow, speed, grapple, swoosh, slash, land, depth, stack, grapple, swoosh, here.
to this. Hey there everyone! So as I've said in the intro, today I want to share the process I went through while redesigning the sound for this clip from Ghostrunner 2, using ReaperToWwise. There were a lot of interesting aspects I tackled while working on this project. In this video, I'll give you an overview of how I went through this process step by step, starting with, what even is ReaperToWwise? ReaperToWwise is a Reaper script created by the awesome Mark Hazelbell that lets you communicate directly with the Wwise project using simple notes and empty items on the Reaper timeline. These notes can trigger events, switches, states, and much more, all without even leaving Reaper. ReaperToWwise basically turns a linear redesign into something that feels a lot closer to implementation, getting me to structure my Reaper and Wwise projects like I would for an actual game. Instead of just stacking sounds on a linear timeline, I have to treat sounds like in-game interactions, breaking down each action into modular elements that combine during playback, just as they would in a game. I won't go into the nitty-gritty setup details, but if you want to learn more about it, check out Mark's ReaperToWwise GitHub page, which I'll link below. Before we dive into the technical side, let's take a moment to talk about bullet time audio, or slow motion audio. High frame rate footage can look amazing when it's slowed down, but sadly, audio doesn't work the same way. When audio slows down, it loses a lot of high-frequency content, and sounds can easily lose definition and become muddy. As an example, here's my sword slash sound at normal speed, half speed, and quarter speed. Yeah, at this speed it doesn't feel that great anymore. This behavior made me realize that instead of forcing tons of high-end content into my sounds, I needed to design special slow-motion versions of important sounds. These sounds fade in and out based on the game's time state, keeping everything crisp and clear in the appropriate moments. Let's hear a little example. This is the normal speed enemy rifle shot, and this is its bullet time version. This approach let me create a whole new feeling using some different textures and adding the dramatic trigger pull that amplifies the heightened senses effect conveyed by the game. To enhance this effect, I'm adding a long, dreamy reverb that will affect all bullet time sounds. As bullet time ends, it fades out, making way for a more realistic, large space reverb that matches the environment. This decision dramatically affected the structure of my Wwise project, so let's check it out. Let's start by taking a look at the project hierarchy and main parameters. We've got some pretty normal buses and actor mixers set up for ambience, enemies, global audio like the slow motion events, interactables, and the player. And we've also got both our reverbs. In order to treat bullet time audio differently, some special routing was required. Sounds meant to play in normal time are routed to the normal time SFX bus under their respective sub-buses. And sounds exclusive to the bullet time are routed to the bullet time SFX bus. For interactions that exist in both normal speed and bullet time, events trigger both versions simultaneously. Switching the audio between the different time modes was done using these global bullet time start and end events. Aside from playing the bullet time start and bullet time end sounds, these events set the global bullet time RTPC and switch values, which I used in lots of different places to change audio behavior, starting with the two main buses I mentioned. Looking at the normal time SFX bus, we got a few things changing based on the bullet time RTPC. Volume fades in and out, crossfading between the main buses, a bit of filtering to help blend things together and smooth the transition, swapping the reverb sends so the right reverb is active depending on the time mode, and some pitch shifting to add that subtle tape-style feel as the normal sounds fade in and out, just enough to sell the time slowdown effect before the bullet time sounds kick in. Speaking of which, looking at the bullet time bus, I'm only modulating volume and reverb sends. This might seem a bit simple, but with everything that's going on, simply crossfading and turning on the bullet time reverb does the trick. Now that I had a solid plan for how everything should work, it was time to set up the infrastructure. At this stage, I think that it's very important to separate the technical from the creative. Instead of designing, implementing, and mixing each sound one by one, I'd rather keep things simple, using test sounds like
ouchie
for enemy hits and for bullet pass-bys. This way, I can focus entirely on the logic, making sure everything is set up correctly before diving into sound design. I went through quite a few steps to get everything ready for the test sounds. First, I made a list of all the sounds I needed to design. Then, I created the corresponding containers and events in Wise to play them. After that, I generated all of my test sounds.
Don't move! Can we be friends?
Inserting them into the proper containers, and calling their events in sync with the video, using empty items on the Reaper timeline.
step, 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 step.
Next, I prayed that the bullet time setup I created earlier would work, and when it didn't, I fixed and tweaked everything until it sounded right. And lastly, since we weren't connected to an actual game engine, I had to manually adjust the RTPC's envelopes to represent every single sound's distance and panning from the player. My god, that was a pain. Each sound has one RTPC for panning and another for distance, which affects volume, filtering, and reverb sense, similar to how an attenuation curve would work. This manual step was by far the most time-consuming part of the process, so next time I'll probably pick a clip that has a little less 3D action. Finally, the project is ready for the real sounds to be implemented. Sadly, since this video is already getting pretty long, I won't be diving into my full creative sound design process. This is where all the technical setup really pays off. I can finally focus on the creative side and quickly get sounds to trigger in Wise. Once a sound is designed, all I have to do is export it and drop it into the matching pre-made container. And of course, I can't forget to turn off the test sounds.
Please, don't do it, I'll do better, I promise.
From here, all that's left to do is designing and importing all the sounds, giving everything a proper listen, tweaking anything that needs extra attention, and finalizing the mix with all the routing and parameters we set up earlier. Easy peasy, right? That's not a lot of work at all. But seriously, once everything's triggering at the right moment and properly spatialized, the design and mixing process feels a lot smoother and easier. Now that you've seen how everything works under the hood, let's listen to the final result one last time. So that's it. This project was a great learning experience for me, and hopefully an interesting watch for you. If you're looking for a way to create a unique game audio reel, I highly recommend checking out ReaperToWwise. Mark did an awesome job putting it together, and it was a blast to use. I didn't manage to cover every little detail in the project, so if you've got any questions, feel free to reach out and ask. Thanks for watching, and I'll see you in the next video.